Hi, my name is Taylor Morrison. I'm a science teacher in Beaverton, Oregon. I teach eighth grade science at Five Oaks Middle School. I thought I'd show you some lessons that we made with the CE Fellowship. So I'll share the screen here. Um, we're an avid school. We always have an essential question. The essential question for this was, how does our waste and power relate to the environment? And if we go down here, I can show you there's targets and some of our avid strategies, but here it's a storyboard. So I'm a book illustrator. So I made an 11 by 17 storyboard, and the storyboards pace out the lessons. I originally planned this just to be a few days, but the kids got so into it that it ended up taking a couple months. And so we have a storyboard here, and then it's got 6 panels, and then each panel represents a theme and a lesson that we go through related to a hands-on activity. There's also video links here about anaerobic digestion, but always prefer the interactive stuff first. We did make anaerobic digesters. I found the best ones to make were these little bottles here, like water bottles or Gatorade bottles. I found this Japanese fertilizer here. It's anaerobic fertilizer, so you can grow anaerobic bacteria. You put it in one of these bottles, you add vinegar and baking soda as the food for the bacteria. You squeeze up the bottle like this, and then the bottle will eventually expand through anaerobic digestion and fill with methane gas. So that's a great little hands-on method. Been doing it 3 years now in the classroom, so it's pretty fun. So it's good to start that experiment first because it takes almost 2 weeks for those bottles to get ready. Then after doing that, you go straight to the storyboard. So the first storyboard, what keeps us alive and where does it come from? That basically talks about the environment, how we relate to the environment, and how it supports us. A lot of kids don't go outside in nature a lot, so I do try to take them outside, and I do try to show them how the environment takes care of us. So the star is you. You can put this on a whiteboard or a big screen or on a TV. And then as you just do a discussion, so kids will say heat, the sun, the atmosphere, water, food. So it's a good interactive discussion where I ask the question and the kids will will get into it more, and they get credit for good questions or good comments. Then we also have some vocabulary down here. We talk about an anaerobic digester, bacteria, things like that. Okay. Anaerobic digestion is it's digestion. So one thing, here's the directions. We take Cornell notes. You can write the essential question. I find that it helps kids a lot to actually write and then do a diagram and hand draw on the computer or paper. Tends to get them more engaged and away from the distractions of social media, video games, things like that. So we do take a bottle, crush it, and wait about a week, maybe more. That's the anaerobic digester experiment. And then this one here is about hydrolysis with sugar and water. It's a simple little experiment you can do that explains, hydrolysis is a part of the anaerobic digestion process. Okay. So those are the Cornell notes that we set up. Another experiment involving digestion is an elephant's toothpaste. So we do write the materials, the procedure, we draw a diagram, make a chemical formula. We set up the pages like this. The reason I showed this is, it's kind of funny with middle school that they'll want to go up and grab all the materials and start the experiment. But this, doing the procedure, the essential question, writing things down is essentially their ticket to do the experiment. So, yeah, they basically need to come up and present this before gathering materials because they'd much rather gather materials and not take any notes. But anyway, that's how you start. Okay, here's some former students that are doing the elephant's toothpaste. I mean, we do read, we do vocabulary, but they really do love the hands-on. Below is a picture. I tried to make an anaerobic digester we could use in the cafeteria. I went to a Clean Water Services. They're a great partner. They actually gave me raw sewage to put in this thing. It was supposed to It looks cool, but it was a plastic cow, I called it, but it did not work. So I'm hoping to, I don't know what happened, but anyway, it was a good experiment. But the little bottles I showed up top, those did actually work. So, and I, recommend those for the classroom. This thing is still in my garage. Okay, some more experiments here. Uh, Different ideas you can do. Here's the second panel of the storyboard. Central question is, what is the balance of the carbon cycle? So, um, in order for kids to begin to understand climate change, because it's so intimidating and huge, that it is good to understand the carbon cycle and that fossil fuels are a part of the carbon cycle. So we do go through the carbon cycle, we label it together, and then relate it to the clean energy lessons by going to the fossil fuels and showing how they give us power through factories, cars, and electricity. And that releases CO2. So it's an introduction. Okay. How does the carbon cycle give us life? This is a fun one that you can take the kids outside. I'll show you examples of what they did. And so here's the blank one. And then you take the kids outside, you get a leaf, you do a rubbing with a crayon. I mean, I know it's kind of maybe more for elementary school, but it's still these physical things I find with a world of iPhones and computers, if they get to use their hands and do something physical, it tends to wake them up, and having more fun while you're learning science is a good thing. So that's our carbon lesson. And then we do our school has switched to physics, so I'm redoing these lessons to have a physics base, but these can also be used for chemistry. And I'll show you examples. We make models of carbon and methane molecules, and methane, again, relating to anaerobic digestion. Okay, so here's two storyboards. So you do the storyboard first, take the notes, do the hands-on experiment, and then come back to the storyboard. So it's a cycle as well. Okay. The next one, the third one, what happens to our water? Since this cycle anaerobic digestion revolves around wastewater treatment plants, we do have a discussion about where our wastewater goes. Again, most kids don't know. They don't know what a wastewater treatment plant is often, or that there are digesters in these wastewater treatment plants. And so if we talk about the water cycle, it does relate it gets them thinking about ecosystems and that everything's tied together and ties into the main subject as well. Here's a slideshow here in this lesson. If you click the slideshow, it's a tour I took of Clean Water Services. They're a great company here in Oregon, and they are very open about their information, and they actually they did show, here's an anaerobic digester at the plant and in the drawing right here, okay? And they're going through the process of cleaning sewage water. Okay, and then one of the things about cleaning water is it has a lot to do with density. The water comes in, the heavier, denser particles will sink to the bottom, and that's one way they start cleaning our wastewater. So this is a fun little experiment here where he's using a carrot and freshwater, salt water to do a density experiment. The salt water makes the water more dense, so the carrot floats, but the carrot is more dense than the fresh water, so it sinks, and it's a good way for them to see something and get excited about it while it changes. All right. Okay, here are the Cornell notes to set up that density experiment. Okay, and then that's the end of lesson 1. So if you want to see over here are these are contacts, these are links in the slideshow, but this is student work. So these students find drawing really helps. It's good for science. A lot of scientists do draw, doctors. Here's the anaerobic digesters. They squeeze them and then they watch them expand over time, expanding with methane gas. Here's the sugar hydrolysis experiment. It has to do with digestion. Here are student notes about the elephant toothpaste experiment. That one's a lot of fun, very messy. I would do it on a lunch tray. So it's easier to clean. And then the clean energy storyboards. What happens to our waste? You can see on these, again, the students have a discussion and write, and I find it makes the information stick better so they can learn it, also go home and tell their families about it. So here is what is the carbon cycle, what happens to our wastewater, the water cycle, and more, okay? It ends with the essential question, how are we changing our atmosphere? So that would be the start of lesson 2. So if we go back to lesson 2 here, this is the end of lesson 1. We go, and lesson 2 is here. So lesson 2, the essential question, how does our waste and power supply relate to the environment? All right. So here's the storyboard again, the link. Here's articles about the water cycle, the greenhouse effect, anaerobic digestion here, and pH. So one experiment you can do with pH that we did is set up the Cornell notes. And with wastewater treatment, it's very important for them to get the correct pH of the water before releasing it back into our rivers and lakes and the ocean. So a good activity to get kids to think about pH is this red cabbage chemistry. Maybe you've tried it before. Basically get red cabbage, boil it in water. It really stinks, which is fun, makes the room smell bad, but in a fun way. And then you make this purple dye, and they can come scoop out the purple dye, cabbage soup. And then here, one of my students is basically mixing baking soda, vinegar, and if you haven't done it before, based on how acidic or basic the material is, it turns the cabbage juice different colors. So that's a pretty fun, exciting thing to do. All right, and then you saw the student example of this storyboard. In the essential question, is our atmosphere changing? Okay. And as kids hear so much about climate change, it's on the news. It's very intimidating. You hear about polar bears and forest fires and droughts and hurricanes and talking with students over the years, if you ask them, can you basically explain climate change to me or to your family, what is it? And pretty much they're all stumped, is what I found. It's really hard to explain. It's so huge and intimidating to talk about as well as think about that it's really difficult for kids. And I think people in general, everybody. So one way to start is we've talked about, is our atmosphere changing? Yes, it is. So when we go back to this, we have been talking about CO2 gas and carbon dioxide and methane, CH4. And the kids learn that the CO2 is coming from gasoline, oil-powered cars going into the atmosphere. It's also coming from factories, coal-burning factories. And then methane is coming from livestock, farms and ranches, animals. It's also coming from landfills, from food waste. And what relates to anaerobic digestion is that instead of, we'll talk about this later, but instead of going to the landfill, the food waste can go to the digester. But in this lesson, we're just talking about the actual change to our atmosphere. And some of the vocabulary words would be greenhouse gas, atmosphere, CO2, and methane, and the greenhouse effect and thermal radiation. And some kids, they hear greenhouse effect on the news, so they think, well, the greenhouse effect is bad, but it's not bad. It's just, I think it's important to teach kids that it's the greenhouse layer is important to keep us warm. It keeps us safe. Without it, we'd be as cold as the moon. But with it, it keeps us warm. But when you have too much of these gases released in the atmosphere, it's like a blanket that's too thick and then starts getting too hot. So that was one way in our discussions that we tried to make sense of what's going on. Okay, talking about the greenhouse effect, it's important for kids to understand gases, like that they're actually there, because sometimes I've had students that don't even believe there is CO2. So one way to prove that there is CO2 and it's heavier than typically the air we breathe, you take 2 bags, paper bags, take a lot of it. All the directions are here. You take vinegar and baking soda, mix them in a bucket, and the buckets will tilt. It's pretty fun. And then also using dry ice, which is pretty simple, getting it at the grocery store, is also another way to show that CO2 is a gas. You can see that. Okay, here's the bags. They do tilt, and when you pour CO2 in, kids usually want to see it 2 or 3 times because they don't believe it, but it's a fun experiment. And here's the dry ice. You can see the CO2 gas raining down. Okay, it's chemical formulas, some more videos. More about the greenhouse effect. You can show how the temperature rises with more CO2 versus less. You can do that with these bottles here. Here's the directions, and I'll show you pictures of students doing this. Also, relative humidity. This is another thing, very simple. You can do with a washer and wet a cloth and spin it around. And you can see with increased heat, you get increased evaporation, and increased evaporation creates more violent, powerful storms. So in these 2 experiments, very simple things. Again, I love the hands-on. It wakes kids up. It's more fun for them as well as myself. Have to give, procedures so they're not, doing stuff that's a danger to each other. But yeah, you want the CO2 bottles and and I can show you pictures of how this works. Okay, and here's the setup. You basically just thermometers. Any kind of thermometer will work. You put it through a stopper into, so you have 1 bottle with air and water, 1 bottle with Alka-Seltzer and water, and then the one with Alka-Seltzer heats up faster. Okay, and then here's the heat lamp here. Okay, and then you just have thermometers in the top that they can read. All right. So, what are the costs of doing nothing about climate change? Here's one of our last storyboards. Again, this is a tough lesson to talk about. It can be harsh, but I found with kids, it's better to get things out in the open, to talk about them, to expose them, and then they're less intimidating than when they're avoided or when they're not talked about. So increased drought, wildfires, eutrophication of the water, pollution of the water, hotter summers, all that stuff is very intimidating, very scary, but when we get it out in the open and talk about it, it's less intimidating, and then we can talk about solutions to make it better. Sea level rise, etc. All right, we're back to the bottles. We did make anaerobic digesters, which are a part of the solution. And here's a photo here. There's also a video on this lesson. And you can see we did create actual methane gas with this process. It's fun to do with the kids. You can take them outside. They like to see if they can ignite their bottle. And it smells terrible, so they have fun with that too. It's pretty funny. But and then our last one, what can we do? So try some optimism here. After that grim spread, we can improve soil. We can plant native plants like we do at our school. We can use the digester. The digester will give us power in poo-powered cars, kids like that, or cleaner power in the electricity. We also have renewable hydrogen, solar power, using less fossil fuels. There's lots of things that we can do here to make improvements. Okay. Renewable hydrogen. I was people on CE had a panel of professionals that came and talked about renewable hydrogen. And there's a fun experiment that you can do to create hydrogen, where you have 9-volt battery, a couple copper wires, and you can make hydrogen bubbles through electrolysis. And here's one of my students doing it here. All right, and they always have their notes so they can record observations. We don't just copy notes. We make observations, we have discussions, we try to have polite disagreements about things that you may think happened or didn't happen. And so we're really teaching them to be observant. There's another way that you can do hydrolysis with a battery and salt water. All right, so that's lesson 2, and then we can look at some examples of student work. So here we have, sorry, checking the computer. Okay, so here's the example of what happens if we do nothing. This student here did it on the computer. Interesting approach. Some of them use styluses and computer art. This student also drew it on their Chromebook these computers they use. And some of them get into it. They also have their little touches of creativity, which is nice. What is carbon and methane? Oops, sorry about that. What is carbon and methane? Here's two different examples of diagrams and notes. A really beautiful diagram here. And water quality, this is the experiment with the carrot, the salt water and the fresh water, and density in our wastewater treatment plants. Okay. Carbon cycle, some beautiful leaf diagrams that use microscopes. You can expand this to use in other ways. Here's the greenhouse gas lab experiment. You can see the two bottles, and the students are using heat lamps to heat these up and get different effects that way. And it is interesting for them to see that one bottle is getting hotter than the other that had the Alka-Seltzer tablets in it. Okay, here's more experiments with that. Notes from that same experiment with the thermometers. And here's the experiment with the bags. So all of this is included in the lesson. So writing out the procedure, if some of these experiments maybe seem a little intimidating, writing out the procedure really helps to reduce fear for the kids. They feel more in control. And I think it's also for the teacher as well, because if you write everything out, you can be like, well, did you do this? Did you do that? So it helps with accountability as well as empowering the kids so they feel like they can know what they're doing and follow directions and pay attention. Here's another lab too about, this is, if you want to do extra, you can use lime water. You can exhale into a bottle and actually create carbon. And this is actually what, it can explain what's happening with bleaching coral reefs. But that's a class that was going really fast to make calcium carbonate, and we had some extra time to do that. So that's an extension you could do here. Okay, here's our renewable hydrogen lab with notes and supplies. All of this stuff is very simple, very inexpensive. Our science department doesn't have much money, but I try to make really enriching lessons. So we're doing all we can, sorry about that, with what we have. Okay, renewable hydrogen, renewable hydrogen. Okay, I think stop this. I'll be happy to answer any questions or share ideas. The lessons have been great. Originally, they were designed for 2 to 3 days, and we ended up doing them for a couple months. My school has a sustainability unit that didn't have any curriculum in it, so this filled that very well. Anyway, thank you.